let's see, let me just kind of walk you guys through this. I'm going to grab a little timeline here and just roll it all the way back. And we'll start right at the beginning of this thing. I mean, you guys know the drill. Starts out with the image sketch that we're trying to trace over, and then we go into the center line. That's a measured center line. And then I took it all the way back to right here to the surface revolve. And this was one of the things that I kind of came up against with your file, James, was like you had been super diligent about following along with the steps that I took in class. And so I ended up just kind of baby stepping through your file and comparing it against my file, kind of looking for flaws, looking for inconsistencies. And there's, you know, the kind of overall of how I had kind of pitched this project to you guys was, well, let's do two half revolves, two 180-degree revolves, and then join them together kind of midway through the process, with the idea that there's going to be a different arc on the top than there would be on the bottom. So that just seemed like it could be cleaned up. And after trying it a few different times, trying to get it to work, I just couldn't get success. I couldn't repeat the success that I had recorded earlier and posted to your guys's and posted to the web. So I was getting pretty frustrated, and I was really just began to get super focused on like, let me just simplify every part of this model to as much as possible. So in the new build, I start with a full 360-degree revolve, just to make sure I have one solid surface to deal with, and also to lighten up on the design tree, which is always a good thing. If you can get your design tree to be as short as possible and kind of eliminate the fluff, then your file will be easier for you to read, easier for other people to read, and it'll be easier to pick through when problems arise, because they certainly will. So let's see. I go through and I do the original split, and I cut out that section, and then I start hiding the surface bodies that are left behind, and I'm just focused completely on this one trimmed out section from the main revolve. And then I go through and I make the two planes at the front and back. And, you know, I haven't gone into complete detail with you guys about planes yet and how do they work, but I do remember that, you know, we've gone through the process of, you know, taking planes from, say, the standard planes, like a front plane or like a right plane, and maybe, you know, here's the top plane, and you can pull new planes off of those ones. Okay, there's that way. We've also, I think you see me go up here to the reference geometry tab and go down to the plane button that's here, and there's the way to turn on the plane tool, and then you have to kind of set references. Like if you want to set a reference to, you know, like the top plane, it'll create a new plane that's right in line with the top plane, and then you can set it at a certain point. Like, let me see if I can just put one right here. It'll start with that forward orientation, slide the plane forward, and then stop it right at that point. Another thing that I haven't talked to you guys yet about is to take a plane and to put it onto a flat curve. And then after hitting the flat curve, you can see how it lines itself up vertically with that flat curve. If you're looking here, it'll perfectly line itself up with that line. But then the second click can be at the end of a curve. And what it will do in that way is it will kind of read the angle of the curve, and then it will place the curve perpendicular to whatever the trajectory of that curve was. So you can see this one, it's very subtle, but it's kind of sitting at like a little microscopic angle. Okay, so that's another way that you can set a plane, is by hitting a curve and then hitting the end point of that curve, and it will kind of end up at a certain angle. So let's see if I just start like a new file here and kind of look at that. Or maybe a better way to do it would be like this. If I show you guys, like if we go to new plane tool and we click this flat curve right here, and then we click the end point of that curve, it will stick a plane right at the angle of that C shape right there. See that? So that's super duper helpful if you think about it, because this is another technique for kind of breaking us out of the XYZ space of SolidWorks, which is really the kind of dead giveaway for models that are built in SolidWorks. That's the kind of bad reputation that SolidWorks has, is that it only creates blocky stuff, and it's really hard to make anything that's not, you know, really engineering or anything like that. But once you learn how to set planes at any custom angle that you want, then you really get away from that stigma, and you get full flexibility within the program. And you also gain, or you also still have the same really strong capability with creating standard XYZ type engineering models along with really organic stuff. So I got suspicious that perhaps when I was pulling planes off and setting them at this point here, that I might be creating them at some sort of microscopic little angle, and maybe that was causing us quite a bit of trouble. So I reset the planes using the actual cut line that I used to cut this surface out with. So I just set it just like that. So that one click on a flat curve will give you a flat plane right at that location. So having those reset made me feel a little bit better. I continued on from there with boundary surface. We know all about this, along with the surface extrudes to get them set up for the mirror operation. And I just was very, very careful kind of going through the steps of this thing. I got to this point right here in these two boundary surfaces. I got to this point where it was time to do the two boundary surfaces and to trim them. And so I used a new trim tool, which is this sketch right here. So again, this is a thing that I did to, again, minimize the clutter in the file. So we had these two kind of arced curves that used to be in two separate sketches, and we were using each sketch kind of independently to trim off one half and then the bottom half, and then we make another operation for this half and the bottom half. And I thought, you know, we can just combine that whole set of sketches into one and then use that for the trim operation. So here's the trim kind of in action. You can see it's one fell swoop. It takes off all four corners of the surface we were trying to affect, and it really cleans up the file. So it does take a little bit of extra work drawing that out, but it made for, again, a lighter design tree, a more efficient model, and just less stress too. Just one click and you're done. So the next thing I did is this boundary surface, and I'm pretty sure that this side boundary surface might have been what led to so much frustration on my end last night, because at a certain point, about midnight last night, I started doing like a three-sided boundary surface where I would just, I guess I got lazy or something like that, and I would go top, bottom, and then I would just take this arced curve that's right here. There's an arced curve here, see it? And I would just use one side of what should be a four-sided situation for the boundary surface. And what that did is set me up for, I think, some trouble. If we look at the rest of the model here, here's the rest of the thing. You think about this arc right here, if you guys are watching, and you think about it driving towards this wall, and if it's totally arced and remains arced as it comes around here, it may completely miss the entire wall here, and there could be gaps in between this edge and the boundary surface that's here. So one of the things that I did in this new model is I really made sure on this boundary surface that I had an arced curve on one side, but then I had a flat curve on this side, and I used just a straight curve for that. So there's this thing in animation that's called tweening, and it's where you draw a shape one way, and then you draw a shape the other way, and then you select both shapes, and the computer will calculate all the different morphing shapes the item must go through in order to change from one shape to another. And those are called in-between shapes. So they call it tweening. And so if we think about this surface here as like a tweening situation, you know, this surface is going to start out as an arc here, and then as it's told to run this direction towards this straight line, it's going to slowly flatten itself out. And so my goal was to see if I could have better success by putting this straight flat line here. Now, I have to go back and look at my own work that I uploaded from class last time to see. I'm pretty sure that we did a four-sided boundary surface in class, which is why I was probably able to get it to work in class, but not after the fact. But I think this was a really key part. And so for anybody that hasn't done their homework yet, I'd recommend, you know, paying really close attention when you get to this part of the recorded tutorial, because it's important. So, and it goes for both sides as well. So as I get down the design tree here, you can see that I did the same thing on the other side. Let me hide these planes to just keep it simple. You can see that this line is totally straight right here. So, and you can also see that this surface starts out with a little bit of an arc into it. One thing that was unfortunate was that I was playing around quite a bit with the arc on these two curves. And I know in class I had brought up quite a bit about how I wanted this to have like a brow, and it should really say a lot about the aggressiveness of the product. And unfortunately, it just, the more angle this line has to it, the more kind of opportunity this surface has to sort of miss the surrounding surfaces and create holes in your model, which won't allow you to knit your surfaces together or create fillets later on. So this is one of those situations where it's like problems now might not seem like they're going to do anything, but then later they could. So I had to really, if I just edit this sketch right here and look normal too, I had to really go light on the angle of this curve and keep it as kind of flat as possible, but still maintaining the design language. And the bottom line is, if we wanted to go with something super aggressive, we could, but it would just take a lot more time and manual patch building to get it to work right. So because of time, I just said, well, let's still try to get an arc in there, but maybe not so much. So there's that. Those two surfaces need to be set because they need to interact with the rest of the surfaces really well. So yeah, here's the part where I kind of redid my work, and I revolved a whole new 360-degree revolve into the model. And this is when I was making my first tutorial. I was like, I could have done this back up here. I should have done this before. So you'll see it when you watch the video. But the idea here is that once we've got all these upper and lower surfaces that are matched to this individual surface here on the bottom, then we can introduce an entirely new 360-degree revolve so that we have full overlap between these two boundary surfaces and the larger revolve. I had previously trimmed the surface and had a hole in the middle kind of before I started these boundary surfaces, and that just was not working well. So it seemed like starting with a full 360 and chopping it up and then adding another 360, it worked for me. So I'd recommend that as well. Let's see, so we'll just keep going down this thing. So in here is just a bunch of trims. This is the part where you guys might remember, you know, you start with a split to get the last piece cut out, and then you go through a number of trims to get all the interior pieces cut out, and you end up with the shell of the model pretty much figured out. And then comes knit, and knit took a couple tries. One of the things that really discouraged the knit tool to work was this boundary surface down here. This is the one that Mo, you and I spent a ton of time on it, and James, it turns out, it seemed like it was your issue as well. If you haven't done your homework yet, this comes into play a lot. So the bottom line with this thing is that in class I had taught everybody to do a curvature continuous blend here with these two curves, curvature continuous blending into the surface here at the back. And it turns out that's just a little too much geometry to allow us the flexibility to move this surface around as much as we need to. So with this one in particular, if I just open it up and show you guys, this curve right here, this front one, is the culprit of quite a bit of kind of stress and strife throughout the class. So let's take a look at it and kind of show you guys what the deal is. So unfortunately, the way this model is kind of displaying right now, it's causing a lot of the model to disappear. Let's see what we can get to show up. Yeah. Yeah, it's best if we look at it from this way. So when I did this in class, I was very militant about the idea that we should, attach this curve to this edge. And then in the new video that I came up with, I'm using a new technique, which is to use a pierce command. So if we click on here and we take a look, there's a little green and orange icon right here, a sketch relation. And a pierce command is just like a coincident relationship. It's just like one of those coincident sketch relations that will stick a endpoint of a curve onto another surface. But it just adds an additional level of geometry, an additional kind of step forward as far as like the actual touching of the two pieces. So it's something I thought we could get away with, and I'm not quite sure if it's the make or break thing with this model, but it should be, we should bring it up and talk about pierce command, because it's the kind of thing you bring out of the toolkit when things aren't going your way. So it shows up on its own and it looks like this. So when you click the endpoint of a curve and then you hold down Control and then you click the edge of a surface, so you go endpoint, edge of a surface, Control, and you'll see this little icon right here, make pierce. So it's right next door to the make coincident icon, and the two icons actually give away a little bit more information about what the tool actually does. So if you're trying to bring two curves together, two endpoints of two curves and make those stay together, then the coincident relationship is, it's the one that you'd use. It's for 2D objects. But if you're trying to get a single curve to stick to a 3D surface, then make pierce is a little bit more appropriate. And the icon gives that away. So you see the 3D surface with a little curve sticking onto it. It sort of reads the geometry, captures the 3D-ness of it, and just kind of goes from there. So it sort of lines up the curve with more information than the coincident relationship does. So we're just trying to give the computer as much math as possible so that it doesn't fail and it can do its job. The other thing was, these curves had just a lot of different sketch relations that had popped up. There's this one here, the circle with the dash through it is the tangent, and my model has completely transformed to all tangent relationships. So when I went to go and blend this curve to this edge right here, I went ahead and just added a tangent to it. And then later with the boundary surface, when I set the boundary surface up, I set the boundary surface to tangent to face, see here, and tangent to face over here as well, to match the geometry of the curve. So I didn't force a curvature relationship here just because I wanted consistency completely on this model. So I just want to go back to this curve again and just show off that if you really look at how this thing is kind of landing as it comes around this corner and landing on the surface, it really does help to accentuate the gap between the curve and the surface as much as possible. And when you have the tangent relationship on there, you're able to wiggle this curve around and pull it out and kind of lift it up off of the bend of the barrel, and that saves your life. If this thing dips down into the bend of the barrel, it's lots of problems all over the place. And the really the worst kind of problems you can run into with a SolidWorks model, which is the microscopic ones that you need to zoom all the way in to see, or that you can't see, and you know, problems come up. So yeah, so be careful for that one, guys. Let's keep going through my model here. Just walk you guys through it. Right. Let me hide this. Okay, so yeah, here's another just a little quick example of, you know, I'm using the planar surface tool here in this instance, and I just go ahead and capped both ends with one planar surface. This was the part where I really got hung up, was trying to get this end here to land planar with fillets on the model. And so I pretty quickly realized that if we had fillets on the model, that the end here was going to really have trouble being flat. So that's kind of where I started last night, was like, let me take the fillets off and see if I can get everything to work without fillets. And I did, but then I ran into more problems later. And so eventually I got all the way back to the starting point. But using the surface plane tool here on two different open ends, it's just another attempt to, you know, keep efficiency in the model. I have two here. I have an additional surface plane for this opening. I'm not quite sure why, but anyway. Next up comes the knit, and looks like knit's failing on this one right now. Let's take a look why. Oh, because I've got my two surfaces going. So yeah, this file doesn't want to be opened up and played with again. Maybe these fillets will fail as well. Yeah, so there you go. So the big takeaway is to just make sure that when you're building this for your second or third time, go ahead and try and start out with a full-size revolve and move on from there. And if you're watching the videos from last class and you're following along with the advice to do 2 half revolves, then you're just going to end up with a situation that's more complex than needs be. And so yeah, that's my kind of my big aha. So yeah. Let's see, who else did their homework for class today? Ulysses, did you do any homework? Did you get this thing done?
No, I haven't finished it yet. Not yet.
Let's see. I have Sylvia, I have your file open, and I have Harish, I have yours here too. So Harish, you're having a problem on yours where fillets just aren't working, right? You had sent this to me.
Yeah, exactly.
Did you get any progress made?
Yeah, I was able to do one side. On the other side, I was able to do once like the top surface, but the bottom surface, I'm still facing a problem. But I think like if I adjust the curve, it'll be fine, I think so.
Yeah. Yeah, it really all comes down to these little degenerate points. You know, these things need to be pretty dialed to get them to work well. You can see here the fillet trying to work until it gets to this point, and sometimes adding this little bit in can help. I've also had a lot of glitches in my program as well. I'll show you guys. I'll just open up Photoshop really quick and show you one which I ran into today. Which is an interesting one to look at. Just wait while Photoshop opens here. Yeah, so if you guys can see this, then you can see what I'm talking about. So I got the whole thing to work. James, this is on your file last night. I got the whole thing to start working, and then I flipped it over and realized I had this strange effect happening where the new surfaces that I had added were showing up as transparent and see-through, but then when I would roll the model over, the top would be see-through, and I don't know what to say. It was a hot mess. Did anyone see anything like this?
No, but my SolidWorks is for sure buggy.
Yeah.
I know that much.
Yeah, I don't mean to talk smack, but I think your file in general, the one that you sent me up here, R3 at least, I think it had just been taken to the cleaners and was starting to act really funny. I mean, I put myself to bed last night in frustration. I was dedicated to finish the work, and I couldn't get my computer to act right. It was glitching pretty hard. So much so that I started taking screenshots, which is pretty big for me. You know, I have stuff happen on my computer all the time. I don't pay attention to it, but trying to record videos as well as doing live SolidWorks was not working well. So
Jim, I have one question.
Yeah.
So to how do I solve this? Like, do I need to just pull the curve outside so that it changes the shape and it works?
Yeah, I think that it's going to be a matter of going back to the boundary surface that's running on this side of the model. For you, Harish, what I would do is I would bail on the mirror and everything, since the half is not working right. Then I would go back to the drawing board, and I would roll this right up and just work on one side at a time, as opposed to trying to mirror it over and then solidify the mirrored version. That's more work than you have to do. We really only need to get half of this thing finished, and then we can do the mirror once everything's perfect. So I would step backwards till before the mirror and then see if you can get this thing to solidify. You can see there's a little bit of a strange coloration here, and this is the problem area for a majority of us, myself included. So I can't say if that problem is impossible to fix, but let's see, you've got a surface knit right here. Does the surface knit bring those two things together? Is there a hole that pops up when the knit? Yeah, see, there's a sliver that opens up when the knit is taken off, and then it goes away when the knit comes in. So yeah, I would go back to this original surface, and I would adjust this curve right here until it's correct, until it starts working.
Okay.
Yeah.
Thank you.
Yeah. And that goes for everybody too. Today, what we're going to do in class is we're going to take our binoculars and we're going to open them up into an assembly file, and we're going to start some work on an in context assembly file for all of this. So it's nice to see that, you know, some of you guys got started on adding some of the other details. That's all good practice to have. But in typical fashion, as we close out the class here, I'm really kind of eager to get you guys into the habit of redoing your work and taking things on and off and so on. So that might happen again. So if you did get yourself to a mirrored state, then congrats, but we're gonna backpedal ourselves to another position sooner than later. So let me close your file, Harsh.
Sorry, Jim.
Sylvia, here's your file. Do you want to, anything you want to tell us about it while I've got it open here?
Not really.
Let's see. So it's pretty easy to kind of walk through this and just, you know, using the design tree, we can, you know, discover things pretty quickly about your model. I mean, one thing is that, you know, you were able to get everything to solidify into a single solid body. Then it looks like you've got some of the eye socket things started up here, and then you mirrored it to the other side. Maybe let's take a look.
Yes.
Mirror.
In the very
Right.
bottom.
So there's the mirror. Okay, and like I said, this is all good practice and stuff, but what we'll do today is just kind of start from scratch on this stuff, because there's a lot of detail in here that we need to get done. And as we'll see, we're going to want to do that in a separate file on its own, and then bring it into an assembly file. So even though I told everyone to do this as homework, it's all just, you know, kind of water under the bridge practice for what's to come. So. Let's see. So did you follow the videos like step by step? How did you figure this out?
Yeah, I followed the videos, and I noticed in The one you try to do the planar surface to see if the top one is a planar,
Mhm.
but I didn't do that part because when I try to make it, it just is straight, so I don't have to do that part.
I see.
Yeah.
Yeah, well, everything here looks pretty good. Did you have problems with this boundary surface down here? Did you have to adjust this at all? Did you do any work on that?
Yeah, I adjust this for like 5 or 6 times.
Good. That's the right move. Yeah. Good.
Uh-huh.
It's a test you passed.
Yeah.
I just click on this curve here and we take a look. So, you know, yours is one of the unique ones where you've still got the curvature continuous setting on the curve and you've got the tangent and the coincident relation. Now you don't need all that. You know, I'm happy to see that you were able to get it to work without that, without having to take that off. And this is a perfect example of like, you know, me and Mo and James, we were fighting this thing nonstop, and the solution was to take this stuff off. But for you, you were able to get it to work. I have another file where it did work with these on there. I was getting situations where I was trying to do my final knit operation, and I would do it 2 or 3 times, and every time I would get a different warning or a different rebuild error. And that's when I knew that I was starting to, I was getting tired and my computer was kind of giving up on me. So it was time to just kind of switch gears and go to sleep and start another day, and that helped a lot. But I was getting warnings that were saying things like, we cannot knit this surface because it's a 0 thickness geometry, which doesn't make much sense. The other one that I got was, it was said we cannot knit this because of a geometric condition, which that's just like almost no detail. That's like saying, you know, you're getting a warning that says just nah. It's just doesn't any doesn't really give you any detail. So
And also, after I adjust the curve and sometimes the fillets just not work, and then I pull the timeline above the fillets and redo a fillet of that part, and it works.
interesting.
Yeah.
Yeah, well, you know, I mean, you guys saw the file. I just pulled up my own file that had been working. I just opened it and scrolled through the design tree, and that was enough to break a few fillets. So the fillets will be the thing that breaks, which is why we always put them at the end of the process. So you can take them off and put them back on as needed. So here you go. Apps and everything. It looks like you were able to use surface plane to get them to all come together. Very good. And then here's the rest of the mirror and everything. Cool, so you're on the right track. This is going to be a good file. I'm happy to see it's worked with plan A as opposed to plan B. So
if this file works, do I have to do another one?
no, you don't need another one, but I would use this as a starting point for building the assembly file, which we'll do today a little bit in class. So like I said to Harish and everybody is, you know, the mirror here is not going to be necessary. We really only need to build half of this thing to make it work. And we can perform the mirror at any time as long as one side is working. So that's why I say this is a good start, and it's totally a usable file. And, you know, homework to turn in today was just to show that you had started the file and you had an in progress file going that you could work with so you can keep up. So yeah, I would just, if I were you, what I would do is just open this file. I would just give it a new name, like maybe you're at R3 right now, change it to R4. If you feel like taking off these 2 mirrored items, we can rebuild those in an assembly file. You can follow along in class if you want, or after is okay. And yeah, go from there. And then just leave one as it is, and it's a good benchmark of kind of where you started the project.
Mm-hmm. Yeah.
So here's Mo's. Mo, what's going on with yours? Yours looks good. You got some really sharp looking fillets here. They, you know, everyone's different. You know, that's the name of the game with this thing is that endpoints of these multi-fillets really do kind of take on a life of their own for every different file. So let's just check here.
Hey, Jim.
Yeah, Mo.
Yeah, I actually used the mistake file, the wrong file to change something, to fix something. Then I got this. So you said about the sharp edges. So yeah, I haven't put the, what's that called? The blah 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 circular. I just used the normal fillet, not the not the magic
That's
one.
okay. Yeah, you can call it. It's a circular fillet. It's a normal fillet. Yeah, that's okay. Yeah, I mean, I would see what you can get away with. You can always jump back into these fillets once they're created, and that's when you have the flexibility to try out curvature continuous. Have you tried this yet?
I tried. It's failed. But I think, but I think we can adjust the top and bottom to the curvature, and then we can adjust the middle things, the biggest one, as the to the curvature.
Yeah. See, here you go. It's working as a it works on the top one, and then the bottom one fails. So yeah, these fillets, they just need a little bit of it's order of operations. Same thing we talked about over the phone. And what I was recommending to everybody, you have to really play around with when you add these fillets. Do you add this one first? That was working for a number of attempts, and then adding these side ones one by one was working in class. By the end, after my studies, I was able to get all of these fillets to run under one fillet operation. So yeah, the more time you spend with these files, the more kind of opportunities you'll see to kind of improve them along the way. So yeah, very good. Okay, cool. So this looks really clean. You've got another interesting fact about yours, Mo, is that you don't have a split going in this section here. So you just, let's see, what did you do with this boundary surface here? Did you split the surface and then re-revolve? Like, how did you get rid of this split line in the final model?
I
see what I'm saying?
No, that's magic. Probably in the surface need number 3, I pack them as one. Is that possible?
I mean, here it is, right? We see it if we go back to surface knit 3, and then we put it, and we do the knit, and we go through, somehow it disappears when you mirror your file. Look at that. So it's there, pre-mirror, and then you do the mirror, and it disappears. I think you're right. I think it is magic.
Is that true or not?
No, I'm joking. I don't think it's magic, but I do notice right here using the timeline that if I go back before the mirror, that it's definitely there. We all see that right there. And here's the mirror, and it goes away after that. And some way, it also, this whole surface becomes one. Let's look at the mirror. Let's right click and edit the mirror.
Yeah, I'm looking the mirror on my end.
Okay,
So,
there's a knit surfaces option inside of the mirror tool, and it looks like you have it checked on yours. So that might have been the thing. This button right here might be the thing that
I should check the merge solid.
Well, I'm not sure because, this is not solid at the time that you mirror it. So your solidification doesn't happen until the very end of the thing. If you wanted the mirror to solidify it, you would have to add these caps and put the mirror down at the bottom.
Okay.
Let's try it. Let's try it. We can do that. So we'll take this off. We got planar surface. There's one. Let's clear these out. Do 1, 2, and 3. Is it working? There's 1. Doesn't like this side one. There's 2. There's 3. Okay, so that's all of them stuck together, and we can grab them all, knit them. No, we don't even have to do this. We can just, we can take off this one too. Perfect. So if we take all of these and they're all capped and we mirror them, then we can perform the
That's right.
bodies, knit surfaces. Hit merge solids. And we can't knit sheets together. Well, okay, so look, when you mirror it without, that's interesting. There's that. Same amount of things in the design tree, actually. You save one surface plane by putting the mirror at the very bottom of the tree. Interesting. Okay, cool. Your file was cleaner. All right, cool. Here, I'll save mine. I'll save. Okay, cool.
Wait, Jen.
Yeah.
Should I have the separate part, or should I not have the separate part?
The mirror? Or
No. Yeah.
I think that you should keep your model just like this, just the way it's
Oh,
here.
okay.
Yeah, I think you should. I think that having a clean surface on this edge, it's a little unclear as to why it's doing that, but since it is, I would take it to the bank. You know, I would use it to your advantage. I mean, you saw me, I just tried to redo it, and when I did it, this was all broken apart into different pieces.
Gotcha.
We're still going to need to do quite a bit of work on these surfaces, guys. So, you know, let's, you know, get into that kind of later, but, you know, don't forget, you know, to really, if you guys don't have the initial set of images that I sent you from the Vortex website, then, you know, make sure to get your hands on these things, because we're going to need all this for inspiration, trying to get all of these little offset surfaces and everything into the build is going to be a bit of work, and depending on, you know, what is going on with your model, you know, it's going to be easier or harder depending on that. So I think, Mo, for yours, having this whole cylinder here as a clean shape will make it easier to do these kind of cuts and offsets and stuff like that. So
Gotcha.
yeah. Cool. So that's a good place for this one to be. No problems there. On the right track. Very good. Okay, cool, guys. Yeah, you know, another thing that I had done too was I actually opened up a little quick, I had even made like a little Rhino file too. Let's see if I can go to open and see if I can find it to try to show you guys what this thing looked like in Rhino. I might have gotten rid of it though. I don't think that I saved that. Let's see if I got it working. Either way, this was pretty hard to do in Rhino, but it was basically the same technique that we've been doing in the class for the SolidWorks version. I've got a tutorial on it kind of somewhere. Here's my tutorial in Rhino. temporary, but you can see here, you know, just going back into Rhino, pretty quickly you realize the difference in SolidWorks and Rhino is the edit points, and having to adjust the edit points that go into the curves, trying to capture the, you know, clarity and the detail in all of these little curves is really difficult to do in Rhino. You have to really understand kind of where to place all of your edit points and how to adjust all your edit points so that they land horizontal at the center line. This is what I'm doing in this part of the model. And then here I am drawing again the curve that goes in the center there, and then connecting the two. So I've got this tutorial as well. I can upload it in case anybody's ever feeling like they're a little bit more Rhino inclined. This is the kind of project that'll kind of teach you like that, you know, both programs are capable of doing the same thing. So here in this scene, I'm actually just taking this curve here, and I'm using something called match curve to blend it into the C shape of this trimmed surface. And it's an interesting thing, you know, as I was working the file, I started to realize, well, I really need to be in 4-panel view so I can work the flat view and then watch it happen. So the curve ends up being totally whacked out and stuck in all sorts of different angles, but from the front view, it looks totally clean. So there's a lot of like projecting, using the project to C plane item to flatten out the curves afterwards, and then trying to use the relocate gumball tool to grab the curve and move it back into position after I'm done building it. Here I am resetting the gumball's position so that I can stick the curve right onto the end of the surface. Same thing I was doing in SolidWorks. So there I go again, trying to match this curve here to the back C shape and flattening it out using project to C plane. And then here I go with, I started out in Rhino trying to do a sweep 2 rail. If you guys remember sweep 2 rail, right? So since we had these 2 rails sticking off the model, I thought, well, maybe I can kind of wing it and get closer with just 2 rails. It ended up being okay, but trying to blend this surface into the other surface of Rhino turned out to be more difficult than I thought. I wasn't able to get the level of clarity that I really wanted, the level of blending that I really wanted using the 2 rail option. You can see down here in the 2 rail command line or in the tool itself that, you know, there is the option to add edge continuity or edge blending to your 2 rail sweep, but mine was grayed out for some reason. So so I went through a couple of different options. Here's the realization that I came to, which is a much better example of bad surface blending. So these white and black lines, the zebra stripes that we played around with in SolidWorks, they are a little bit more accurate inside of Rhino. And so you can see here this ugly stagger, that like stuttering on the word stagger. You can see that thing there and it's bad, right? And that's the kind of thing that would show up in a keyshot file from a mile away. So I went back to the drawing board, and instead of doing a 2 rail sweep, I busted out this tool called the Surface Blend Tool, Adjust Blend Tool. And this actually gives you the ability to click 2 different edges of 2 different surfaces. And then you can set the level of blend that you want. And notice that, you know, one of the things that Rhino kind of says it's good at that SolidWorks doesn't do is, you know, Rhino will give you 2 additional levels of blending beyond the curvature blend. So in SolidWorks, we have curvature blending, and that's the best blend you can get. Rhino has G3 and G4, which is just more of the surface here will be aligned with the surface here, depending on whether you're on G3 or G4. So like in SolidWorks though, the more blending you add to a surface or to a curve, the less flexibility you have with that curve. So if you try to move it or massage it or get it looking better in any way, there's less ability for that. So these buttons down here are kind of like, they're like novel, you know, they're not really used that often, but they are there for looks. So yeah, so I kind of go back and forth trying to get these two edges to blend together, and I got pretty good along the way. And I started using another idea to take this whole patch blend and pull it away from the model, and then use a surface blend between this patch and the half trimmed revolve. And that one worked okay, but still it was a small little patch and didn't seem to be the right move. So I blocked in the back end. You can see me, I blocked in the back end to give myself a 4-panel setup. And then I used the, here I am just adjusting the back curve and kind of struggling to get it to lay flat. And it didn't want to. Keep going. And so here I am using network surface again. So once you have a 4-panel setup like this, just like we've learned before, you can use network surface, and network surface seemed to be the best move. And here's why. If we look at the toolbar for network surface, you can see here that I have full options for all 4 corners between position, tangency, and curvature. So here's the setup that I've got going. So it's edge number D that's touching the rest of the model, and that is you know, the one we want to set to curvature. So I set that as curvature, and then I also set edge B, which is this one up here, to curvature as well. And that gives you the perfect zebra stripes. Still, there's a little like ridge or ripple or something there, but it's pretty much a good blend across the entire seam. And so here we are at the end of the video, and yeah, totally perfect blend. And kind of here's where it ends with just sort of like step 1. And so organizing all of the layers and getting the curves to land flat and getting them organized and snapped to the model in just the right way turned out to be, I think, about a half an hour of work to get me to this point here. And definitely I was able to achieve a lot more than that. I was able to actually make the entire homework assignment in SolidWorks in 40 minutes. Like I said, it's 2 40-minute videos. I timed myself twice now, and so I'm at about 40 minutes for the build. And in Rhino, this took 20 minutes, so I can imagine it would take probably about an hour plus without practice. So you can see the timeline here on my video recorder is about 25 minutes to get to this point. But the moral of the story here with showing you guys this piece in Rhino is just to show you that, you know, the strategy and the build structure and the kind of techniques of trimming surfaces away and blending surfaces into other ones and, you know, merging everything together. All of that is standard issue, whether you're using Rhino or SolidWorks, it doesn't matter. So you really need to kind of think in your heart as to which program you prefer and which one lines up most with the kind of design work you want to do. And don't let anybody ever tell you that like SolidWorks can only do one thing or Rhino's only good at one other thing, because both programs have the same capabilities as each other. They're just suited for different types of people with different interests and different workflows. So that's a big part of being in school, is trying to figure out what types of workflows are you into, you know, and trying to get that dialed in. So we teach both programs in the class. So looks like from the look of this, I didn't save my work. What a bummer. Too bad. Yeah, practice makes perfect. Rhino. Okay, here's Rhino. We don't need Rhino. Hold on. Okay, cool. All right, you know, it's just about an hour into class right now. I'd like it if we could take a break a little bit earlier today. Since we're just about to switch into the next part of the binoculars project, which is building the assembly file for it, I want to take a little breather before we get there and just sort of set up my file so that it's ready to go. And if you want to do the same, then what I would suggest you do kind of right away is make yourself a single folder somewhere on your computer that can be for, this will be Jim's Bono file. It doesn't have to be that name, of course. This will be your personal file where you're going to keep all of the CAD files that go into the assembly. So as we prepare to create a new assembly file, let's plan ahead. Remember the thing about the assembly files, guys, they are linked files, and we want to create a really strong link. So first step to creating a really strong linked file situation is having one clean folder on your computer where all your files go in. So I'm going to do that with my files. I've got, let's see, I think this one, these fix-up ones, is my latest and greatest. I'm going to put that in there, and then we can save the assembly file in there. And if we start making drawing files, just you want to have this dialed in. So make sure to do that while we're on a little break here, and we'll come back in 15 minutes. That should be just about 8:40, and after that we'll have an hour or two to get in, start making the assembly file, and start making some of these details that we see in our promo imagery. Okay, so why don't you guys do that, and we'll come back at 8:40. And anybody got any complaints about that idea?
Nope.
Cool. All right. I'd like to now show everybody your file. Let's take a look, everybody. So Chloe sent me her file here, and it looks good. I mean, it's coming along. The only issue is this fillet up here at the top wasn't working. Is that right, Chloe?
Yeah, and I think it has a little gap. I'm not sure you can find that. I'm not sure where is the gap.
No, no. Well, the reason I wanted to show everybody anyway was because I fixed it, and I fixed the fillet problem here, and it was pretty easy. So I just took your timeline. I'm looking at the icons. I roll it up before the mirror, so we only have to do one side. And then I grabbed the fillet tool here, and kind of like you were saying, like,
You'll see the gap.
do you see it?
In the base part, in the bottom.
Oh, that? I see it now.
Yeah.
Oh boy.
Yeah.
Yep. That's so we just click on this surface, and then that'll highlight this boundary surface. And so it's the same problem that everybody's been having. The curve that's running here off your boundary surface needs to get adjusted to bring this surface down. So, but I wanted to talk about this fillet thing. So let me finish what I was going to say. So 1 millimeter fillet is where to start. And up here at the top, you try to add it, and it kind of doesn't work. So one of the big realizations that I had myself after doing this file a few times was this button right here, tangent propagation. It's just one little checkbox, but if you uncheck it, it actually worked for me. So I reset that, and I add this little bit there, turn that off, and now it's stalling. I have this, oh God, here, let's try a smaller one. Looks like I've got a lot of edges chosen in there. Let me get just one of them. There it goes. Okay. So with tangent propagation turned off, you'll get this scenario that I told you guys about where SolidWorks is just being glitchy and it's being weird. And so it's only giving us a partial preview. There's a button here that's called partial preview. You can set it to full preview if you want, and it'll give you a better preview of what it's trying to do. But yeah, it turns out for this fillet here, all it takes is just to uncheck that tangent propagation. This thing right here, just uncheck that, and then you should have the ability to add even up to a 1 millimeter fillet, which is what we all want. And we'll try for curvature continuity. Looks like it's not going to take curvature, but hey, we can also not tell anybody. There you go. So just because, you know, Chloe, we have a lot of people in the class who have still not started this at all. And so when they get there, they're going to want to know about that button. So thanks for sending it in.
Okay, thank you.
Yeah, and then let's see, we can just finish what we're thinking here. If I click on this thing right here, it'll open up the item for your boundary surface. And then what you want to do here is edit this curve. Just look at it from the side view. And yeah, so your curve is still in the same boat as a lot of us have been recently. So I'm just going to take off the one with the C. And I'm going to just leave that as it is. And then you should be able to just flex this curve out a little bit, kind of look at it. You're just trying to build a better little gap in between the curve and the surface. And then when you exit out of that curve, boundary surface should come along. Maybe some other stuff will break, but let's see. The gap should be fixed. Yeah, so the gap fixes itself. Some of the fillets stick around, and then some of the other fillets need to get redone. So I think this one might need a little bit more something or other. I'll leave you to solve it on your own. Let's see, it's starting to work there. Looks like 0.25, 0.5, 1. There you go. All right, so that's happening. So it's such an odd thing, you know, about this model in general, that somehow adjusting this bottom surface, not the top one doesn't have a problem, but the bottom one, with adjusting that is really the key. So your problem is fixed in here with that, and your fillets are now all running, so that's good. So here you go.
And also when I make the mirror, and if I click the neat surface, it cannot work. But I'm not sure if it can work now, because you fixed the gap.
Yeah, let's take a look. Let's see if we do this. The knit surface would definitely not work with that gap because it wouldn't be attempting to. Yeah, it looks like it just did work. Yeah.
Okay.
So there you go. Okay, cool. So there you go. Let me save this up.
I just tried the tangent propagation thing.
Yeah.
It didn't work for me. It just like the model went so crazy. It broke all the parts actually.
Jesus. Harsh, no. I'm sorry to laugh if that makes you mad. It broke all the parts.
Yeah, it just broke all the parts.
That's really strange to me. But you know, yeah, go back to those original surfaces, that boundary surface and everything, and fiddle around with it and really try to adjust all those little connection points, because as we're finding out, those lines that flow into the other surfaces will set you up for success for the fillets later on.
Okay, so when I'm like adjusting the curve, like I removed the curvature thing that we use, like we use control and do the curvature, right? So I removed that, then I adjusted the curve, then when I do the curvature thing again, it just goes back to the same position, right? So what is the point in like changing it?
It should be a little bit more flexible. Like you should be able to get in there, and you should be able to take this curve here, and sorry. Once it's set to having just tangent and this piece here, you should be able to flex it and pull it like this. Do you see?
Yeah, I tried that, but I'll send you the file. It's not
Okay.
working.
Yeah. But keep trying it, because it's a subtle effect. It takes a long time to get it right. You have to try it a bunch of times
Okay, sure.
until
I'll
you
do
get
it.
until you get a really clean situation.
Sure. Thanks. Thanks.
Yep. Okay, so let me close this down. What we want to do, guys, is we want to start up a new assembly file. So I'll show you guys. I've got my folder here, and I've got my latest and greatest file that I'm working on. Put this on list mode here. Hold on. Okay, so here's all my files so far. I went ahead and changed the name from my file. I changed it from like whatever it was, fail to fail R8 because I have a couple of R6s. So I'm actually going to change the name one more time and just take the word fail out just to give myself a little positivity. All right, so I'm going to take this and I'm going to put it into my new folder for my main assembly. Paste. Okay, that's step one, is get your file into the right spot. So you should have a folder where all your files are going to get made and all your assembly files are going to go. Okay, this is kind of like the manual version of the pack and go feature. If you guys remember pack and go from the last time I made you do assemblies, you're kind of like building the final result of a pack and go for yourself. Okay, so even if everything goes haywire, you know where to go to get your files. The next thing we're going to do is make an assembly file in SolidWorks. So I'm going to say new, say assembly. As usual, the assembly file always asks for a part right away. I'm going to actually not add my part in right away because I want to set up the assembly file a little bit more. So your assembly file might say begin assembly over here, and you can just X that out. And then I'm not sure how your computers are working, but mine is opening everything with centimeters. So I want to make sure to set the units of the assembly to millimeters because that's how my first part is made. And then that's really kind of all you have to do to get your assembly file working is you just have to set the units, and then you want to use the insert components button. So if you go up here to the assembly tab and you go to insert components, you can click that, and that brings back the whole window and everything. And I'm just going to go here to my, let's see, folder here. I'm going to grab my part and I'm going to say open, and be careful at this point, guys, because we want to make sure that we do this trick where you don't just drop the thing anywhere. You drag your mouse over and you set it down into position by dragging your mouse to that green checkbox and clicking and letting it sit. So that way it should arrive in the same orientation as the rest of the workspace. So let's just test that right now and make sure we're on the right track. Let's see. So we've got our right plane is here and our right plane is there. So yeah, that works. We got our top plane down in the bottom for the assembly and top plane. And so good, we're all set. So front plane and front plane. Perfect. Yeah, okay. Yes, that's centered. Okay, good. Nice. Okay, so anytime you start a new assembly file in SolidWorks and you insert your first part, you go in and you save that assembly file. And this is the part that creates the link to the part file. So anything you do to the part file outside of the assembly will show up in the assembly. And anything you do inside the assembly will show up in the part file. So don't forget that. So we'll just go File, Save. Let's make sure to give it a name that we'll remember and save this in the same folder as where your first part file is. So I'm just going to call mine ASM R1. Cool. All right, that's done. Okay, good. Also notice that I'm really just going to be working like half the model right here. I might temporarily mirror it just to give me the visual that I need to kind of build other parts in context. But I really don't want to overload my brain, so I'm just going to kind of start out by doing it this way. So there we go. Okay, so I mean, the first thing we got to do is go back to those reference images and really take a good hard look at what we're sort of dealing with here. If you've got some eye holes that are already built, then I'm going to suggest that we try to build those things all separately because they'll be a lot easier to add detail to. But we can do separate parts here in the assembly. As you know, we're going to do in context modeling where we'll model this piece in the context of the assembly, but we'll also do what they call bottom-up assembly, which is where you start here at the bottom with a blank assembly file and you build up from there. So we're going to be doing two types of building in this final piece here. So it'll be worth it, I think, to just get in here to the part file and see. I'm going to go edit part, and that's how we activate the part inside the assembly. And then I'm going to go down to the sketch that has the photo. I'm just going to show that. Perfect. At that point, I can exit out of the assembly and I can be good from there. Since we're in an assembly now, we do have some additional options here nested within the design tree. So it's good to pull this thing out. Let's see, this one here at the very end in the fourth column will ghost your models so that you can see through it. And this is specific so that you can build around your model. Okay. Just going to take a glance around here. SolidWorks add-ins. I don't feel like I need the add-ins tab up here in my assembly file, so I'm going to right click on it. I'm going to go to tabs and I'm going to uncheck SolidWorks add-ins. There's a few others I could get rid of, but that one in particular seems a little bit not interesting to me. So I'm just going to zoom in here and we'll take a look. I mean, I could quiz you guys on this, but I'm not going to. You should be just kind of, taking personal inventory in your own head and taking a look at this and trying to think, what do I have to do to build these components? Pretty clearly, there is a circular pattern happening here and a series of revolves. But if we combine that with some of the investigation and some of the photos that we've seen in other files, if we go here, right, we look at, let's see, this photo is really revealing as far as like, what does this thing really look like in real life? So first of all, these eye pieces are, they're not anything to sneeze at. They have some serious like form going on in them. So we should all be paying attention to that. And then also pay attention to the fact that it looks like there's some sort of rubber gasket on the inside. That would be like the eye cup. That's probably a light blocker or something like that. So this exterior piece is for padding around the eye. And then this is probably for blocking the eye to light so that you can get focused in on what you're looking at. So then you've got the glass underneath that. So just in this piece right here, I see 1, 2, 3 parts just for this eyepiece. Down here in this lower corner, I can see that there is, it looks like some sort of plastic lip that's sticking up that's actually part of this strap handle that's sticking out. And in order to get this thing to work well, we're going to need to make a little cutout for it to stick out. So I would say maybe that's like probably the place we want to start is maybe building something like this, considering it requires us to build more than one piece. So we're going to need to build, we're going to need to not only build this piece, but also edit the main body of the binoculars as well. So just trying to paint a picture for you guys when you're at home and, you know, it's your homework assignment to look at these photos and figure out what you need to build, how you're going to do that. So really keep your eyes peeled, no pun intended, but you know, for all of these little plastic pieces, everything in here is designed, everything's manufactured. If you were to look at a parts list or do like a product teardown on these binoculars, how many pieces would you get? That's kind of how I do it in my head is, you know, I really think about like, you know, all the different components that need to be built. If you can build them all, then you can, the detail will shine through in your final renderings. Other things to pay attention to, you've got kind of a blocking revolve right here. That's one height. This one is much thinner and it looks like it seems to have a little bit of a gap in between it. So this is not a symmetrical piece. We're going to have to build one thing for one side and another thing for the other side. So pay attention to stuff like that. But right now, just as an example, why don't we dig in and try to build this thing and we'll see how it goes. I haven't practiced this yet, so it's going to be a little bit of just kind of winging it, but I'm into that, you know, so let's try. Okay, cool. So what I'm going to do is I am going to start my attempt at this by taking a look at the planes that I have to work with and trying to figure out where do I want to start this new part file, okay? So I'm going to try to build this thing. I'm either going to try to build it right on top of here, or I'm going to build it on the ground up here, and I'm going to place it inside of this. So why don't I actually, I'll do this. I'm going to start by actually editing this piece here. So let me take off the transparent effect. Let me go to this piece here, go into the design tree. I'm going to go edit part. And I'm going to look normal to, let's see. Once I'm editing this part, I'm going to go here to this surface here, and I'm going to make a sketch right on that surface. Look normal too. And the minute that I start editing this part in context, it turns blue and my toolbar up here changes to all of the part making tools. So I'm going to find the center of this area here by just nuzzling around the endpoints and clicking. So I don't quite know how big I want this circle to be, but what I'm going to do is I'm going to cut an indentation into the top of this eyepiece here so that I can fit the new piece into it. So what I'm going to actually do is take a smart dimension, and I'm going to put a smart dimension between here and here. Okay, I'm going to make that a 2 millimeter. Okay, so I got that right there. I'm going to go up here to features and extruded cut. Again, I don't know how far down this thing goes, but I can make a decision on my own. So I'm going to say 5 millimeters. Until I know the exact details on a thing, I just like to pick numbers that I can remember easily. So it's usually whole numbers and very basic stuff. So there's that. Okay, that's a piece right there. I'm going to do one more thing here, and I'm going to actually make a new sketch right on this surface. Another one. And I'm going to go up here to the top view again. And I'm going to start off by just drawing a center line from the center of the circle over out of the wall thickness here and start to draw this kind of shape. Now with this line here, I just want to extend it past the interior wall of the cut I just made. I'm just going to kind of eyeball this and keep in mind what it is, right? This is going to be a strap for a binocular strap. So, you know, it'll help if you know what you're building. Okay, so that'll be enough for me. I'm going to take this center line now and turn it into an actual center line, construction geometry. I'm going to go to mirror entities. Take that, and I'm going to mirror it about this. All right, and now I am going to, I think this needs adjusting. Oh, it's wider than I thought. Look at that. Okay. So. All right, good. About like that. And next thing I'll do is I'll take a circle and I'm just gonna bring it all the way out until these lines are overlapping. Okay, perfect. From there, I'm going to switch over to trim entities. I'm going to trim out the interior of this and the interior of that and these little tails too. Small little details. Perfect. That's going to turn blue just like I thought it would, and that's good news. So this is going to be the kind of main outline for my new part, but it's also going to be the cut tool that's going to cut the wall thickness out here. So let's take a look at that. We'll go to features, extruded cut, flip it so it's going the right direction, and just pull it out like that. Perfect. So that'll give us a little notch right there. Perfect. All right, good. Okay. Now I can detail that out a lot later, but I think I'm just going to leave it right there for now. So there's that. Okay. Now let me think a little bit here. I want to build the thing that's going to go inside there. So we're going to have to make our first part, our first new custom part inside the assembly. So let's do that. Take a look at our planes to start as usual. The top plane is feeling good as far as a place to start the new model. So what I'm going to do is, right, like this. I'm just going to have that plane selected. And I'm going to go to the Insert Components tool, and I'm going to go to New Part. Then you got to click the plane again. There you go. All right. Now, we've been through this one time before, but it has been a couple weeks, and so we want to kind of recap a little bit. So, when you start a new part in context of an assembly, it's going to start with a fresh new sketch opened up, and you'll be inside of that sketch as you open up. Now, I never like to use the sketch that they give me. I usually exit the first one and start my own because I like to be able to check the orientation of the planes. So as you can see here, the front plane is orientated different than the other piece. Top plane is crooked to what we want it to be. So we're actually going to take this piece here and we're going to exit out of the component. The new part has been created. It's right there, but it needs adjusting. So if you remember, we can use mates to mate the planes together to flip this thing to the orientation we want. So we want the top plane to line up with the top plane of the assembly because our other part is its top plane that way as well. So let's do it. We're going to go to mate. Go to mate. Open up the design tree inside the assembly. We're going to go to top plane of the new part and mate it to the top plane of the assembly. And then flip sideways. If you get this little box that pops up, this is just an approval box. You say, okay. The mate tool usually stays on after you use it once. So it's best to kind of check your stuff from there. So here's our right plane is kind of up and in the center. And same there, the front plane is like that, and front plane's like that. So we don't need to add any more mates to orientate this new piece. So we'll close the mate tool. And then we can also go ahead and just take that mate that we just added. We can take it off now. Now that we've rotated the piece using the mate tool, we don't need the mate anymore. So just delete it. Part stays in the same orientation. It won't move back just because the mate's taken off of it. It's just, it's in its new way now. So, okay, cool. So this makes our life a whole lot easier. We can now kind of go to town, and here's what I'm gonna do. I'm gonna make a sketch on, let's see, well, first I'm gonna activate this new part. I want to try something. Hold on, guys. All right, that works. Okay, so you're gonna hear a lot of dings from my computer because I'm gonna break some rules. What I just did there is, if you were watching, I created a new plane off of the top plane of the new part. I just went and held down Control, dragged up a new plane, and I set that plane to this section here. And it breaks it first, so I had to reset it. So with the new plane tool activated, I just come in here and click on the edge of that surface that's created inside the hole I just made on the other part. And so what it actually creates a kind of relationship between the part we brought in and the new part we're building. And SOLIDWORKS doesn't like that, so it yells at you a little bit. So I'm going to go ahead and say, don't show again. But if you get this warning, don't worry about it. Just say, okay. All right, perfect. Okay, good. So what we're going to do here is we are going to create our first sketch on that plane. And I'm actually going to go back to the part we were just working on and take the sketch from the cut extrude feature. Okay, and I'm going to go convert entities and put it onto the new part. So there we go. Okay, so we got this new sketch from another part. It's pretty fun stuff. Okay, we can take this from here. See here, here's what I'm gonna do. I'm gonna take that, I'm gonna do a boss extrude. Perfect. Okay, just like that. All right, I just have to check my reference image here really quick. I want to see, does it stick up from the edge here? Yeah, it kind of does a little bit. All righty then, no problem. I'm just using spacebar to kind of move around here. And I'm going to call it just about like that. So it sticks up a little bit. We don't know how much, so we're going to go with something like that looks good. So that'll be that piece right there. Okay. Good. And we're going to want to work this thing a little bit. I want to punch a hole through the top of it so that we can fit the strap through. So I'm going to just make a sketch right here on the top of this piece. I'm going to add myself a little center line here just to work off of. There's a rectangle tool that's in SOLIDWORKS called the center rectangle. It's good for this kind of stuff. Just gives you a really easy way to draw a nice, perfectly centered rectangle by using the center line. I think that we want to make this thing look a little cooler than just having a rectangular punch through it. I think it has it as well. So why don't we do that? Now with the rectangle tool, there's all sorts of sketch dimensions that come along with this thing. There's these dotted lines in the center that kind of hold the sketches so that you can't move them that much. You try to move this and it really just stretches. So I'm going to take these center lines off. And I'm going to take these sketch relations off the sides. There we go. And I'm going to just manually kind of eyeball one side. And one way you could kind of tighten this up a little bit would be to add a smart dimension between these two lines. So let's just call it 100. Maybe a little bit more. Let's call it 110. Cool. And we'll do the same on the other side. Okay, perfect. Now we can drag this thing out and that angle will stay the same no matter what. Perfect. About like that looks okay. I'm just going to make it a little smaller than I think it should be. I might use some more smart dimensions lined up against this piece here so that I can just keep track of how big this thing is. And it's good to see that I'm actually in centimeters in my new part file. So that is a frustrating thing that it keeps making new parts in centimeters, but hey, why don't I just do this? Set that as is. I'm going to put a horizontal, oops. I'm going to put a horizontal relation between the center of my rectangle and then the center of my line here. So that way, if I adjust this number to say like maybe 1.25, should suck in equally, but it's not. So it's a bummer. We can always put 2 smart dimensions on there. Say 0.5 and 0.5. There we go. Adjust this to be whatever you want it to be. I think 0.6 is the number I like. Just a little reminder of how to use smart dimensions to keep things in line and move them around. Can't teach SolidWorks without learning that. All right, cool. So I'm just going to punch this little hole through there. Straight cut through all. Just going to set this to through all both directions so that it goes through all the model. Okay, perfect. Okay, so I want to do a couple more things here. One thing I want to do is I kind of want the edge of this piece to sort of spill over the other part. Like I can kind of see that happening in my reference image here. So I really want to get that because I just think that this area is a cool little area of highlight with the kind of matte finish rubber leaning up against the gloss plastic. So let me just dive in there and do that. I think probably the best way to do that is going to be something like this. I'll just work right off of the top of this model here. This is really simple modeling, so just going to find the kind of center of my workspace here and yeah, just draw out a circle. Perfect. Okay, good. So I want this thing to spill over the edge. It's just going to be a little boss extrude, but I do have to trim it up a little bit. So I'm going to take my line tool. Actually, here's what I'll do. just take these two edges right here. And I'll take my trim entities and I'll trim that away, trim this away, trim this away, and then I'm just going to take a straight line here and connect everything up like that, because I know that I'm going to have the eye cover sitting on top of this. I can kind of make a loose kind of adjustment here. Another option that I might have for this area here would be to use the arc tool that we've used in the past. Take an arc. It's really important when you use the arc tool to see how it jumps off the curve. There's one like that. There you go. That one's a little bit more attractive. So take that like that. Okay, and then we can just do a boss extrude. Okay, cool. I think I just want to adjust that a little bit more. Let's do it this way. I'm not going to be able to continue on in centimeters. Sorry, guys. It's too frustrating for me. Sorry, so let's just go here. Centimeters. Perfect. Okay. I actually think it might be nice to have a little bit of a gap between the new piece we're adding here and the other. So let's see if I set this to 1, it looks like it's about 1 high. So it's maybe 0.8. Yeah. That's a pretty small gap. I think that's kind of doing it. All right, so looks okay. Next move would just be to fillet this thing out like crazy. So let's just do that. I'm actually going to exit the component real quick and dive into the other component and just sort of hide the image really quick so you can see what we're doing. Perfect. All right, this is looking all really good. I can also hide the entire other component here and just take a look at the detail of what we just did. Looking nice, perfect. All right, so fillet tool, let's edit this new part. These fillets here make a difference, so I'm gonna go ahead and set them to like, I don't know, 2 or 3. Remember that this piece sticks out from the product itself, and it's like a very, it's like a touch point, you know? And so you wanna make sure that this thing is soft and round and looks friendly. So. I'm going to do some super small little fillets under here, just because I want to. I think I'll actually hold on that really quick and take a fillet and put it right here. Also, soften up this edge. Yeah. So 2. Okay, that's coming together. That last one I think could be larger. Remember, it's these little details, guys, so you really want to spend a lot of time on these little tiny components. And when you do exploded views and stuff like that, it's the detail on these little pieces that people are going to zone in on. Whoa, that's big. Yeah, it looks like 1.5. Might be a little too serious of a fillet for that, but I'm happy with the way it's looking. Let's try 1, and then see if we can get a 1 millimeter fillet to run around the whole thing. I'm also going to put one on the bottom side. Okay, and then one here as well. That's looking like it's a little bit too much, 0.75 maybe. You see what's happening here is that as the fillet rolls around the hard edge and then hits the other fillet on the inside, it dives in really fast. So you've got to watch out for that when you're laying fillets on fillets. So I'm going to keep going here and finish that. Perfect. Okay, and then I'm just going to check everything by turning my edges off. Kind of see where I'm at with this thing. I still got more work to do under here. And also I'm thinking this whole bit, this is cheesy. I'm not buying it. The 1 millimeter fillet here is just not, it's too much for me. I'll change it to 0.8 and I'll set it to curvature continuous. And if you guys are looking, you know, and you're feeling like you want to learn about some other types of fillets that are available, there's these other types too. Conic row is another one that allows you to set, you have to kind of zoom in on the fillet here, kind of set the roundness or sharpness of the fillet, depending on what this number is. So you can have a fillet that's kind of like almost like a knife point here, or you can flatten that out. And you can kind of just like adjust the steepness of the fillet, but also keeping the setback size, which is what this is. So I don't think it's appropriate here. I think circular fillet does the trick. Curvature continuous fillet looks even nicer. So yeah, 0.8. Okay, that looks okay. Pretty good. Take a little look back on our thing here. You know, I might have maybe messed up just a little bit. I think that there's actually a little cut to this thing here. So I'm going to actually take this fillet off. And I'm going to look at this guy from the side view. And I'm going to draw up a little cut that's going to go all the way around the thing. So here we go. Okay, I'm going to take a center line and drop it down into the middle so that I can, where's my center line? Here it is. Perfect. And we'll do a revolve cut. That cuts off just half of it, not the rest of the model. So that's kind of nice. That looks good. Just a little extra cool factor. Very small stuff, but that's what makes the difference. Okay, good, good, good. And underneath is all that's left. Perfect. So we'll do a fillet. It's gonna go all the way around. Get the outer edge too. Very nice. Okay, cool. All right, now we might as well do this. You know, it's not necessary, but if we do decide to do some sort of exploded view or something like that, then technically this would not be a solidified hockey puck. Okay, this thing's got a hole through it, and we should know that. So let's just add that in here as well, if I can stop myself from doing more and more fillets. But I'll just make another sketch here on the top plane, like normal too. Strike a, let me find my center. There it is. Okay. I'm just gonna do an extruded cut through here. And I'm gonna set the extruded cut to go through both directions. So that way I know it punches a hole through the entire way. This interior ring, I'm going to put a chamfer on. Just because I just have experience with chamfers and little rings and components like this that go inside of other stuff. A chamfer will self-center. So you put chamfers on stuff that nests into other stuff so that they will self-center, so they're easier to assemble and drop in. And then usually there's some sort of little step on the inside of pieces like this so other pieces can nest into them and stop. So the last little bit we'll do on this piece here is this move. Go to the side view. We'll go to hidden lines revealed. We will take a sketch in our front plane and I'm just going to draw just a little rectangle in here. I will give it a wall thickness. I want it to be at least 2 millimeters. And I'm going to very carefully overlap it into the edge of this dotted wall. This is how you use the hidden lines reveal setting. So I'm going to leave that like that. I'm going to take a center line again, and if I can just find the center, yeah, here it is. I'm going to set that to be a construction geometry. And I'm just going to do a revolve boss base with this as the axis. That missed completely. Okay, hold on. Let me do this center line a different way. Hold on. I'm going to take another idea. From here to here, this is the full expanse of the area I'm trying to revolve around. And so I'm going to take the center of this line here, and I'll make all of these construction. Okay, cool. All right, so let's do it. Revolve boss base. It's actually already running, so that. Just got to reset the revolve tool, accept the new setup. Okay, cool. I'm just going to add some fillets to that. Little 0.5 millimeters, something like that. Perfect. Okay. So I'm going to call that done. That is our new piece. This is technically CAD ready. You know, I mean, this is production ready. We could 3D print this thing like we want. You know, we could send it to a manufacturer as is. This thing's good to go. It's ready to accept a couple more parts. It's ready to work as a stopper to stop components from inside of the binoculars from falling out. It's a totally usable part. So we built it in context to the assembly. So this is technically going to be, let's see, I have a red, something's red. What's wrong? Nothing's wrong, it's just glitching. Just show this in connection to the rest of the model. Okay, so with adding this much detail to this piece here, it kind of opens us up to what the rest of this model is going to be like for us, right? It makes you think, all right, well, if I've got this much detail, I've got to detail out the rest of the model as well, right? Like all of these sharp edges leaning up against this really organic thing, that's not going to work. So let's edit this piece a little bit, and we're just going to, begin the kind of typical kind of workflow for a SolidWorks assembly, which is jumping back and forth between different parts and adjusting them kind of together as one. So I don't quite know what to do here, but maybe 3, maybe 2. Okay, bring that up and take a fillet here. Just remember, you can hide these things as needed, so you can work parts of the model. So we're just going to kind of outfit this area so that it accepts the new piece we've built a little bit better. And it's all fillets and chamfers and stuff like that, so don't be too intimidated. A lot of this stuff you won't really see. Oh, didn't we luck out right there? Boy, we all hope to luck out like that, where it makes it around this bend here. I'm going to set that last one to curvature continuous. See if it fails. Looks like it will. 0.25. Could just be too many. Their selections. There we go. That's enough. Curvature continuous around that edge. This thing is going to sing in P-Shot. It's going to look awesome. Okay, cool. So that's that. Exit component. Show the other part. Turn on some of our real view graphics here. Shadows, ambient occlusion. Start to see the detail of this thing coming together already. Just that one little piece right there, and already I think you guys get what I'm saying about how these little tiny details really matter, So, okay. Other just kind of details about, assembly files you guys need to know. Don't forget that you've got some parts that are fixed and some that are floating. So you can always right click on a part and check to see if it says fix or float down here. If it says float, that means it's fixed. If it says fixed, then that means it's floating. Let's take a look at this one. This one is floating. So we can move it out of place like that. So be very careful about this, guys. You don't want to have to do that. Hit undo and just kind of leave it where it is. If you want to take the extra effort, you can always set yourself up with some mates between these circular items. So for instance, there's a mate tool here that you can put a mate on this exterior edge. It's totally wrong, hold on. Turn off mates, yeah. Turn on mates. This exterior edge is, or this circle, any circular item, you can click on and click on another circular item on another part. Hit the button that says concentric, of course. Oh, come on, do it. Oh, you're annoying. Doesn't want to work right now. I'm just going to hit undo and leave it as is. Remember that we've done some tricks here. The reason why that's not working is because we built this new part off of the relationship to this piece, so this thing's kind of built in position as is. So that's good for us. So take note on another fun fact, guys, that we've built this piece inside of this assembly without an additional part file attached to it. So we want to make an additional part file out of this thing now. So the best way to do that is actually just to go File and Save. And when you do that save, you're going to get this pop-up that's going to tell you that it's saving the assembly file. It's saving the edits that you made to your main binoculars, and it's going to save the edits you've made to the new part file. Then you're going to get another warning that pops up that looks like this, and it's going to ask you, do you want to keep this component as a virtual component, which means it only exists inside of this assembly file and does not exist separately, or do you want to create a separate file for this assembly piece? And so we want to do that. We want to say save externally. We can give it a name. It's in the same folder as keeping everything. Okay, perfect. So that just saved that as part 1. Let's go take a look inside the folder that I've got for myself here. There we go. Perfect. And there's part 1. All right, so we're good to go. So let's save that. And let's just do a little quick test here. Let's close the assembly file. And let's open the assembly file back up. All we're going to do is check. It's going to want to rebuild, so we'll say OK. It's going to ask us this. Should we open all the externally referenced documents? And you say, yeah, open them up. That's the part where the link to those part files is drawing those part files into the assembly. Okay, so that is confirmation that our assembly and the links between the 2 part files are working. I'm going to go a different way with it now, and I want to give my new part file a name. So I'm going to call this like let's see, what is it called? Strap holder? Cool, there you go. So I'll give it a name. I'll give it a name here in the folder, and then when I go to open the assembly file, it should capture the new name. Let's test. Okay, so this is another thing. It's going to say, hey, I can't find part file 1, so I'm going to go browse for file, and I'm going to tell it that strap holder is now part 1. And it's going to want to rebuild, and it's going to say open all reference. I'm going to say yes. Okay, and now so the name is updated, everything's good, we're all set. This is a successful in-context build on this piece here. Okay, so we're going to do that just one more time. I think we've got time to do just one more in class, and this one will be just a little bit different, and then the rest of it is going to be up to you for this eye piece here. That'll be your homework over the weekend, is to build the eyepiece. So I just wanted to get one more for us. So got something to do. This one I'm going to start on the front plane. And so I'm going to be making a new part in the assembly, and it's going to be built right off of this piece here. So new part. I'm going to hit the front plane. I'm going to exit out of the sketch. Don't like that one. I'm going to check my front plane is going that direction. Front plane is that direction. Good. Top plane's at the bottom. Top plane's at the bottom. Okay, so this one worked. Okay, cool. So I'm going to go front plane now, and I'm just going to go, actually before I open up the new sketch, I think I'll go here to the top piece. This is the main part, and I'm going to say show, and I'm just going to show my main body here. Perfect. Go down here to the new part, front plane, make a sketch, go here. And you can see pretty quickly we're sort of moving away from the photo, but we'll go with it. Now you're going to get confused, you know, this is going to be difficult to kind of negotiate, but that's part of assemblies in SolidWorks is dealing with complex wireframes. You guys have been in Rhino before. I know you guys can handle it. So grab a straight line here. Okay, so that's the main outline of the thing we're trying to build here. I just need to get my kind of ducks in a row as far as finding the center line here. So I'm going to jump into 3D here really quick, and I'm going to grab a center line. I'm just looking kind of for, okay, anything I can grab onto on the other model. Just to strike a line that goes from one side of the thing to the other. That's kind of doing it. Okay, and then I'm going to take a straight line from there and go straight up from this. It's looking normal too. Cool. That's okay. I'll go trim entities and just trim off everything on this side. I don't need it anymore. Perfect. So now I can just do a revolve boss base with this. It's going to want to know the axis of revolution. Okay, and you guys know SolidWorks. This thing is totally adjustable if we need to tighten up the tolerances or anything like that. So that's good. While we're here, why don't we go ahead and add ourselves a new center line so we can do a circular pattern. Hold on, I just see a quick problem. Here's the problem I'm seeing. This thing is crooked. See that? See that bottom line is crooked? So something's up with my sketch. Yeah, there it is. I'm gonna edit this sketch, the revolve. It's not straight. Or no, this line's not straight. Okay, so confirm that's straight, confirm this is horizontal. Couldn't be anything different. Yeah, perfect, better. Back to front plane, make a sketch. I'm just gonna leave that sketch kind of right there, right in the middle of everything. All right. Again to the front plane. I am going to try to switch into wireframe mode now, just so I can get a general sense of this super pixelated sphere I'm supposed to build. So I want to see about how big that is. Yeah, so it's about like that. And, you know, building a sphere in SolidWorks is difficult because you got to understand what a sphere is. It's a revolved half circle. So I'm going to do that exactly. Let's see here. It's going to go like this. I'm going to use trim entities, and I'm just going to take away everything except this. And so I put a little angled line down here at the bottom so that when I do the revolve, it's going to meld into the side of this thing that I've just built. So You'll see what I'm talking about when I do it. So revolve boss base. This is the axis. Okay, and we'll shade that to show you what I'm talking about. There's our little sphere right there. Okay, good. All right, so we want to take that guy and we want to do a little circular pattern of it. So let's try to remember back to our land of circular patterns. It's been a minute, but it's not impossible. So first thing what we can do is do a linear pattern. Those linear patterns always start the wrong way. Okay, that's that. Your measurements might be different. I wouldn't follow along with mine. Okay, so there's the start of that pattern like that. We'll go to circular. We're going to set the axis of the circular pattern on that line, same as we did before. And this time we're going to open up the design tree, which is getting long now. And we're going to use the linear pattern as our pattern for here. So this needs to be many more instances. Cool. There we go. And that can be adjusted quite a bit, but I wanted to just kind of get us started and see where this ends up. So yeah, more instances I think needs to happen. And so I'll just bump this up. Just let's make it a clean 80, not 82, but 80. Yeah. Okay, and then the other thing that I want this to have is I just want to actually adjust this sketch here so that it's a little bit closer to the piece that we've actually built, like almost on top of it. So I'm just going to adjust that and then everything will update. No problems. So there you go. So I'm going to exit this component, and one last time for the sake of tutorial, I'm going to go through the process of saving the file. So this time I'm going to do it just a little bit differently. Actually click on the new part that we've made here and give it a name. So I'm going to call this adjuster grip thing. I don't know. I might change that later. Okay. From here I can just go to File, Save. I'll go through this ringer again. It's going to say Save Externally. I want to set the path. I always slide this open to see the path where it's going to save the file and see that it's saving it in my new folder. Okay. And I'm going to double check that that's worked. So adjuster grip thing, it's there, perfect. Okay. And so that's it. So that's the workflow for the rest of the model is making parts in the context of our new assembly file that are referencing all of the measurements and detail of the other thing. So for homework, what I want you guys to do is I want you guys to finish this entire ICAP and give me the center ring here as well. I want you guys to use the reference images that I've already given you, the ones I keep referring back to throughout the class. You should have them all, and if you don't, I want you to email me right away and let me know if you've lost them. I want you to really pay attention to, when you do the ICAP here, pay attention to all the points that I pointed out, like the very complex set of curves here. This is not just a revolve, plus there's an eye thing in here, and there's a lens. So you should have individual parts. So homework is going to be 1 part, 2 parts, 3 parts, 4 parts. Don't worry about getting the logo in right now because we'll do that as a group. But this will give you guys a good chance to practice your circular patterns and to get all the other parts as well. Not to mention, you know, at least catch yourself up to what we've done in class today. So it's a little welcome back to assembly files, and the importance of organization is really important. So make sure that you've got your folder set on your own computer. And then for turning in your homework, don't forget the way to do that. With an assembly file, you go to File and Pack and Go, and it's going to give you a list of all of the parts that are going to be sent. I want you to save them to a zip file and double check the name of the zip file. Save flatten to single folder if you don't. I just prefer that, and that's it. So you hit save like this, and what you'll get at the end is a nice little zip file like this that you can then send to me. And also, guys, don't forget to give it a name that's appropriate, like I've been asking you to. Most of you guys have got that, but there you go. So that's kind of what I wanted to walk you guys through today, is the next steps for the binoculars project. Should be good.
All right, cool. Thanks.
Yeah, all right. Anybody got any questions or anything? It's kind of basic from here on out. It's, you know, the parts that are left to build on the binoculars, at least what's for homework this weekend, is super easy revolves, but you can get detailed. That's one of the reasons, just to tell you guys why I spent so much time on that little strap holder, was just because I wanted you to see the level of detail that could go into a part that, I mean, a lot of us didn't even notice was there last week. So I want you guys to really understand and know what to do with small little parts like that. So here's your chance to show it off. So I wish you guys luck.